of the schools, and natural and social sciences is in the chapel because we're the most awesome of all the groups. And so you get chapel credit will be given if you want to do this. So I know that some of you, actually some of you here are on the list of getting awards. So if you're here, you might want to go just in case. Um, yeah, go get your award and take joy. Let's see. So you had homework for today, and I am on the wrong page. Let me just get the right page. Just a sec. Okay, so the right page is section 11.10. Hold on a minute. 11.10. Yeah, so we got a few things we're doing today. There we go, 11.10. I got it. One of which is homework. So give me a sec. 56. There it is. Okay, evaluate. Oh, interesting. The integrals in infinite series. Evaluate, definite. Okay, approximate. Very nice. Okay, so I don't know. We could do a couple of these just for fun, unless you don't need it to, or maybe we will. Okay, so 57, 58, 73. Okay, so let's just take a look at 57 because it looks like the most fun of the bunch. And then we'll take a look at if there's any others that we need to take a look at. Okay, there it is. So 57 is this thing. Give me a sec here. X cubed arctan(x). Oh, you can't see what I'm writing, can you? There we go. There it is. Okay, so this is what we want to evaluate. So let's go to it. And so the way that I'm going to do this is I'm going to write this as a series. And then they want you to evaluate it and approximate it to within 4 decimal places. So 4 decimals. Okay. So the way that we're going to do this is we're going to set this up as a summation. So we all know that the arctangent is this, x to the 2n plus 1 over, oh, this is an n here, 2n, what? Plus 1. Sorry, I was off by a bit. There we go. I believe that's right. Oh, that feels wrong. All right, it's right. You'd think I would know since it's, well, I don't have it on my mug. I have the derivative. I guess I could just derive it from scratch because it is here. But let's go ahead and do this. Okay, so before we do anything else, we should move that x cubed in there so that we can do our antiderivative. So this is going to be the integral from 0 to 1/2 of -1 to the n times x to the 2n plus 4 now. So what just happened was that x cubed got moved in here and it became, you add the exponents. And now we can all do the antiderivative of this thing. This is easy. Oh, I forgot my summation. Okay, there it is. Summation n equals 0 to infinity of this thing. So -1 to the n, that doesn't change. X to the 2n plus 5 all over 2n plus 1 times 2n plus 5. Oh, don't need a dx there, but I do need my limits. So you see I'm cleverly keeping track of the whole thing, and I'm going to do this term by term, and then we'll deal with the whole estimate to the nearest whatever 10,000th or whatever the 4 digits means. Okay, so now you can do this, I'm pretty sure, but just in case, I will go ahead and do it for you. This is going to be times 1/2 to the 2n plus 5 over 2n plus 1 times 2n plus 5. N goes from 0 to infinity. You might say, what happened to that lower limit? Well, when you plug 0 into this, you get 0. So I just am going to ignore it, pretend it doesn't exist. Okay, so now for the magic. We're at this point where we want to know, what kind of a series is this? This is an alternating series. And so what we're going to do is we're going to approximate this using the alternating series test. And the alternating series says that the error, the remainder, is going to be equal to the next term. So the remainder here will be the next term. And the next term is when you plug 1 in. N plus 1 into this stuff. So this is 2n plus 7, 2n plus 3, 2n plus 7. Yeah, 7, right? There we go. Okay, so just if you're confused about what I'm doing, this is an alternating series. The alternating series test says this will converge, and if you stop your, adding up your remainder, the amount left, your error will always be less than or equal to. I shouldn't have an equal there. The error will always be if you stop after n terms, will always be less than or equal to the next term, the absolute value of the next term. So that's what I'm doing here. So I want to know, so now this is like back in the alternating series test days. We want this to be less than 0.0001. And so now I just have to solve for whatever n, and that's going to be too difficult for me. So how about if I do this? I'm going to flip this whole thing and do this. 2 to the 2n plus 7 times 2n plus 3 times 2n plus 7 has to be greater than 10,000. Okay, so all I did there is I reciprocated everything. When you reciprocate the 1/2, it becomes 2 to this. This stuff comes up to the numerator, and that reciprocal is 10,000. And when you reciprocate an inequality, it changes the direction of your little thing there. Now, I think that probably the best thing to do is guess and check. Let's guess and check. I think this is going to be a pretty small number because I know that 2 to the, let's say I put 3 in there. 2 to the 2 times 3 plus 7, I think is already bigger than 10,000 because 2 times 3 plus 7 is 13, and 2 to the 13th, oh, it's almost. 2 to the 13th is 8,000. So let's try this. N equals 3. I get 2 to the 13th times 2 times 3 plus 3 is 9, and that's going to put us over 10,000. And then multiply that by 2 times 3 plus 7, which is 13. So wow, that's huge. 900. That's 958,464. I wonder if n equals 2 is sufficient. Just a minute. So for n equals 2, the number I get is going to be 2 to the 2 times 2 is 4 plus 1 is 11. That's 2,048. Wow, this might be over 10,000 as well. Times 7 times 11. Wow, 150, incredible. So n equals 1, seriously? I just need one term? Just a minute. Let's do this. 2 to the 9th times 5 times 9. 23,000. Well, 40, whatever it is. So n equals 0 if I use 0 terms. Wait, if I go 0, what does that mean? Oh, I just do the first term. Okay, yeah, I guess I need to dial it back a notch. If I have to remember, n equals 0 means I'm just using one term. N equals 1 means I'm using two terms because I'm going to stop it. Okay, let's just do n equals 0 just to see what happens. I'm pretty sure this is going to be less than, I hope. That'd be so strange if I only needed one term. Let's see, times 3 times 7. Yeah, that's less. It's 2. Wow, I should have known. Anyway, so n equals 1 is the magic number. I only need to go to n equals 1, which means that I only need to add up this. Negative 1 to the 0 times 1/2 to the 5th over 1 times 5 plus negative 1 to the 1st times 1/2 to the 7th over 3 times 7. If I add those together, I'll be within 1/10,000th of the truth for this integral. It's going to be a really small number. Yeah, that's going to be a super small number. I guess that, yeah, it makes sense. Because of that x cubed, it's going to be a small number. Okay, well, you can add those together if you want. But that's what they wanted you to do for this, is to come up with, and I don't know if that matches with the back of the book, but that's what I'm computing. So you can compute that and get a decimal if you want. Welcome, thanks for coming. But I'm just going to leave it like that, put a box around it, and be happy. All right, so that's that sort of thing. Let me just make sure that anything below 70 for homework for today on this page. Do we need to look at another one of these, or are we all happy with this stuff? As happy as we're going to be? You're going to be back there, that's fine. I don't know. Oh, yeah, I'm recording, so everyone knows. All right, so let's look at the bigger than 70. Which ones were those? 73, 74, 75, 78. Seems like one of these was especially fun. 73, boring. 74, let's see. That looks sort of interesting. Yeah, each one of these, so 75, 78, 78, that's too easy. Well, okay, they're all, I guess to me, they all look so simple, but to you, you might have looked at those and said, I have no idea. So let's take a look at 74 and 78, since those are not in the back of the book. So 74, they're asking you to add up this, the sum where n goes from 0 to infinity. When I write it out, here, let's see, negative 1 to the n. I'll write it out the way the book has it, and then I'll modify it to be more intelligent. Let's see, over 6 to the 2n, 6 to the 2n, and then 2n factorial. Okay, so that's what they want you to add up. They want to know what's the total here. And so the way that I'm going to do this is I'm going to rewrite it to be one of our special series. So here we go. Make this pi over 6 to the 2n power all over 2n factorial. Now that looks familiar to me. It might not look familiar to you, but you did this quiz for me last time, and that quiz is similar to, oh yeah, it's right there. It's up here. There we go. To this. And you matched up the cosine with letter A here. And so this is the cosine. Notice that that is exactly the same expression that I have down below, except for there's, instead of x here, I have pi over 6. And so down here, what I'll do is I'll say, hey, that is just the cosine of pi over 6. So basically, these bigger numbers is just recognizing what you're looking at and getting it to fit into one of our standard Maclaurin series. So you'll want to be turning back to that page, whatever page it is. There it is, page 768 with that chart on it. And so the cosine of pi over 6, we all know and love, is the square root of 3 over 2. So this equals the square root of 3 over 2. Isn't that cool? Okay. Yeah, what do you think, Eli? No. So on the practice test, this is actually up here, the practice test that I've got online. It's actually last year's test. And you'll notice that on last year's test, basically this is the quiz that I just gave you last time, numbers 10 and 11. So at the very worst, you'll have to do this, is match them up. But probably not even that. Probably I'll just take this and turn it into a regular chart. So this, I will actually sort it out, and I'll have sine, and I'll have this. So it's a little chart. So the important ones from that chart on page 768, I'll just have on the list. So these, maybe I'll throw arctangent in there as well because I like arctangent. So I'll make a chart. I was talking to some people before you got here. Yours is the only exam that I haven't printed up yet. So this weekend I'll have to polish off your exam and get it printed up before next week because we have your exam is Wednesday. So I guess I better get it done so that I can be at the printer. Wednesday, April 30th at 7:50. So don't forget that. We'll go over that again soon. Okay, so let's go back down here to what we were just doing. So there's that one. Let's do one more of these and then we'll see if you have any other questions. And then I've got a little thing to do. Well, a couple of things to do today. So 78 is this. So I'm going to write it as a summation, even though in the book it's written as you've just got 4 terms there, but I think that they're easy enough to be able to tell what they are. You have this alternating situation. So since it's plus minus, I'm going to put -1 to the n. And then you have the natural log of 2 raised to the n power. And then you're dividing by n factorial. So it looks to me like that's what this is. You can look in the book to see this if you don't believe me, but basically the book has the first 4 terms of this. So we're going to have to assume that this is the way this works. So once again, you're going to look this up in your chart, but you might have this memorized already. Oh, not quite yet. You're not looking it up yet. I'm going to combine these. There we go. Okay, now you're going to look it up in your chart, and you're going to say, hey, that looks like one of the ones in the chart in particular. This looks like e to the x. E to the x looks like this. And so I can use this to say that this is going to be e to the negative natural log of 2. So what is e to the negative natural log of 2? Well, that's just 1 over e to the natural log of 2, which is equal to 1 over 2. And so this summation actually equals 1/2 if you add up all those numbers. So it's kind of neat that you can actually take a series, one of these power series that you were suffering with since spring break. I realize it's been a long time since we've been doing this. And you can actually compute or get the exact number that this adds up to. Kind of fun. So anything from any homework except for the homework that's due on Monday that you have questions about, that's what we want to deal with right now. Wow, no homework issues. Okay, so my quiz is actually kind of like what we're doing on Monday. So, which I know, it's like, well, what is the deal there? Well, so what I want to do is I've got a quiz, and it sort of is an overlap because you had to, I don't know, but it's really more of a Monday thing. So why don't I give this to you? As always, I'm not going to collect this, especially since it's kind of in the wrong position. I just got excited about this particular quiz and I wanted to do it. So here it is. And also I have to give you some special instructions about Monday. So we'll do the quiz. We'll talk a little bit more about this topic that's on the quiz, and then talk about the final and talk about Monday. So that's what the rest of today is going to look like once I get this passed. Oh, you moved up. Okay. Oh, you just put your junk back there. I see. Wow, the whole back. What in the world? You're the only one. But back here, you're the dedicated over here, aren't you? Very nice. Here we go. Special. Look at this. I have a lot of extras. There's a bunch of absentees. Oh, Darren, not here. Sad. Oh, I should find this quiz. Yeah, if you're not sure about that last question, the remainder term, don't worry about it. We're going to go over it. But you can certainly do the Taylor polynomial because we've been doing Taylor series, and you're just going to get the first 4 terms, basically. That's your Taylor polynomial. Mhm. All right, well, you probably have had enough time to at least fill out this table up here. It's not all that hard. Let's give it a go, see if we can work this out together. Um, well, I'll just show you what I have. It's not that hard. There's the first 3. Check them out, make sure they're right. See if I did it right, because I might have made a mistake. And of course, the reason I'm plugging 1 in is because if we're centered at 1, then we're going to have our derivatives all evaluated at 1. That's how you do Taylor series. Then I've got my third derivative. I guess that's as far as we need to go because we're doing T3. T3 means third degree. Taylor polynomial. So the highest power is 3, which you're going to see that in a minute. Now that I've got all this stuff, these on the right are the numbers that are going to become the coefficients. And so we don't have to actually make this into a nice, power series. It's just, there they are. So I've just taken those coefficients. So 0 is the first one. That's the constant. And then the 1 here is going to be the coefficient of x minus 1. Then you have x minus 1 squared. That's negative 1 over 2 factorial. So I have a 2 factorial there. And this is 3 factorial. So that's pretty much it, though. It's not all that hard. Yeah, negative 1. Sorry, maybe, is it that you want me to write it like this? Oh, no. No, it's always going to be x minus a to the n. So it's going to be f in at a over n factorial. Sorry, I shouldn't have put that so close. Move this over and make it small. There it is. Yeah, so here's the term. So whatever a is, so a is 1. So we're going to put 1, x minus 1. Yeah, it's not x plus 1. So, yeah, just like this didn't magically, this doesn't turn into x minus 2. It's just always x minus 1. Is that what you're asking about? Yeah, the stuff in the parentheses. Yeah, it stays the way it is. I suppose you could multiply through by the negative, and then it becomes 1 minus x. But still, same expression. Anything else with this? Okay, so that you should have been able to do even if we didn't talk about the stuff on Monday. Well, the stuff due Monday. We've talked about the stuff that's due Monday already, but you haven't done the homework. So there is homework due Monday. But let's look at this. So this is stuff that would be fine even if you hadn't done Monday's homework. But Monday's homework, you have things like this: determine the error term. The error term is just the next term in the Taylor series. So the next term in the Taylor series is going to be this one. So the error term, this is how much, here's what we mean by error, is if we use this polynomial instead of using the original function, how far off are we going to be? Well, here's how far off we're going to be. Now, what is that weird looking tornado squiggle there? That just as I mentioned last time, that represents how far, represents some point between 1 and wherever x is. So the C, that thing, whoops, get rid of that. So this is going to be between 1 and x. And think of this as being, it's some point. We don't know what point it is, but the mean value theorem guarantees that you'll have some point for which this is true. Now, since we don't know what that point is, we usually are going to approximate using sort of like the worst case scenario. So what's the very worst that could happen here in terms of this fourth derivative? Well, I guess I should look at the fourth derivative. Here's the fourth derivative here. It's negative 6 over x to the fourth. Now, really, we don't care. I guess I should do this, put an absolute value around this, because I don't care about the negative. Negative, positive, I don't care. I just want to know how far off I'm going to be. And so really, I don't care about the negative there. But I want to know what's the worst that could happen to that in this range. Well, it really depends on what x is, doesn't it? You see, here's the graph of 6 over x to the fourth. I've dropped the negative. And so if x is over here, then the worst that could happen, the very biggest that this could be, is right there. That's the biggest. If, on the other hand, if my x is over here, then the biggest that this function could be is that x. So it really depends on whether x is on the left of 1 or on the right of 1, so I'd have to adjust for that. But let's just suppose that x is over here somewhere, and we're only interested in values of x between 1 and, say, 2 or something like that. If that was the case, then the very worst case scenario is for my xi to be equal to 1, in which case 6 is the worst that this could be. So I might say something like this, that for x greater than 1, I'll just do that. When x is bigger than 1, then the remainder is going to be less than or equal to 6 over 4 factorial times whatever x is minus 1 to the 4th power. So you'd have to know what value, like if I was going to approximate this for x equals 2, for example, then I would say, okay, the remainder, if I use this to approximate the natural log of 2, which I could do, let me do that really quick. So let's say I plug 2 into this, then the natural log of 2 is approximately equal to 1 plus negative 1/2 plus 2/6. Why did I do it that way? I don't know. That's going to be what? 2/3? Wait, 5/6? So 0.833. I think that's right. Yeah. So that's what I'm getting as an approximation, but how far off am I going to be if I do that? Well, R3 of 2 is going to be 6 over 4 factorial, which is 1/4, times 1 to the 4th. So 0.25. So that's not going to be that great of an approximation. I probably want to take a few more terms before I stop if I'm trying to approximate the value of natural log of 2. Yeah, the actual natural log of 2 is 0.69, so that's definitely within 0.25 of that. Okay, so yeah, what do you think, Daniel?
I'm kind of lost on the maybe like value. So like if you do this problem without drawing a graph of the negative function,
so you want to do this without drawing a graph? Okay, yeah, we can do that. So let's say so first of all, let's back up for a sec because I know that what everyone really cares about. I know Daniel wants to know a more deep understanding of this problem, but probably most of you just want to know what would you get A for on the final. So this is what you would have to write down, something like this, because that's all it's asking for. It's asking for the remainder. So all the rest of this is fluff, bonus stuff. But no, let's answer Daniel's question. How do we know? How do we know? So let's do this with a different number. So let's say that I'm going to use T3 of x. So that T3 of x is this thing up here. So use that to approximate the natural log of 0.5. So let's do that just to see how this works. No, that's not going to, well, let's use this to approximate 0.9. Yeah, that'll be more fun, just for me. Okay, so that's what I'm gonna do that. And I want to know what is the remainder? What is the remainder of this? So how far off can I be? So I know I'm not quite answering Daniel's question quite yet, but I will soon. So first things first is I need to do this approximation. So to do that, I'm going to have to copy this and paste it down here. And we're going to just replace all of the 0.1s, or all of the x's with 0.9, which will give us 0.1. But so we have 1, whoa, that's weird. 1 times 0.9 minus 1 plus negative 1/2 times 0.9 minus 1 squared plus, I'll just write this as 1/3, 0.9 minus 1 cubed. And this is going to be T3 at 0.9. This is much more realistic in terms of using Taylor polynomials. We aren't going to use a Taylor polynomial to approximate the value of a function that's really far away from the center. Usually it's something closer to the center like this. So let's plug this in. And don't worry, we'll get back to Daniel's question, those of you who are keeping score here. So let's see, this is 1/2, that's 0.5. That's going to be 0.005 minus 0.000333. I believe, I better double check my mental arithmetic. Give me a sec here, because I'm probably, let's see. So let's see, it's going to be 0.1 squared divided by 2. Yeah, 0.005. Let me just do the other one. 0.1 cubed divided by 3. Scientific notation. Yeah, I got it right. Okay, so let's just add these up now. That gives me negative 0.099, no, 95333. I think that's right. Let's see. I better double check. So that 9533. Yeah. Good. Okay, so that's the approximation. So this is an approximation for natural log of 0.9. So the question is, how close are we? Well, we're going to use this remainder. So R3 is going to be the fourth derivative evaluated at some point over 4 factorial times x minus 1 to the 4th. So it's the next term. And so in this case, we're doing R3 of 0.9 for factorial. I'll get everything except for the one that Daniel wants to know. So Daniel wants to know how do we get this when we don't, if we don't graph this. So let's go ahead and get, first of all, the function. The fourth derivative is, what was it? Up here, oh, -6. So that you could do. So there's that. And so now you just have to use your knowledge of these things. You want to find, so here's what we're doing. I want to find the biggest that this could be. So what's the biggest? That's a terrible word. Should be largest. This could be between our point. So our point here is 0.9 and 1. So what's the biggest that this could be between 0.9 and 1? Well, even though we aren't going to graph this because Daniel said I'm not allowed to, I still have to use my understanding, my knowledge of functions that I learned back in pre-calculus and calculus to understand that this thing, well, let's get rid of the, there, make it the absolute value. That this thing, 6 over x to the 4th, is, I know what it looks like. It decreases. It's a decreasing function, which means that the biggest it will be is when x is 0.9. So I guess that's what I'm going to do. So I'm going to cheat, and I'm not going to graph it, but I still have to sort of harken back to my understanding of what this function does. Now, if I didn't know that, I could use optimization. I know, go back to Calc 1, take the derivative of that, set it equal to 0, and then find critical values in this range, then test the endpoints. But this is a monotonic decreasing function, so I'm just going to test the endpoints. Not only that, since it's decreasing, I'm just going to do the left endpoint. And so that's all I'm going to worry about. So the very biggest that could be is going to be 6 over 0.9 to the 4th. So let's see how close I am. Give me a sec here. So 6 divided by 0.9 to the 4th. I know, tedious, isn't it? Times 0.1. I know it's negative, but I'm raising it to the 4th power. And then divided by 4 factorial. Wow, I got 3.081, or sorry, 3.81 times 10 to the -5th. So I'm within 1/100,000th well, 3/100,000ths of the truth. So we can actually check this. There's the value that I got, which means I'm good up to this digit. So, or well, that's the first one. That's the first questionable digit. I should do that. Yeah, that's the one. So 0.953, I'm good there. Let's actually check. What am I doing? Natural log of 0.9. Natural log of 0.9 is, whoa. Wow. That is not, something is awry.
Because you have 0.005.
Oh, okay. Yeah, I am off by exactly that much. It's supposed to be negative? Oh, it is supposed to be negative. Amazing. Look at that. Let's get rid of that. And then this becomes 0.105333. Okay, now that looks better because now on, yeah. So the questionable digit is this one here. Okay, sorry about that. Yeah. Yeah, so now actually the actual natural log of 0.9, if you did it, is 1.10536. Wow, it's almost exactly within, because I had computed that here is how close this is to the truth. 3.6. 3.8, sorry, 3.8. So it's actually almost exactly the difference between the truth and my approximation. In the approximation, it's a 3 there. In the truth, it's a 6 there. And that's almost exactly the difference that I would have predicted. That's amazing. Okay, so anyway, there it is. I don't know, that probably is way more than Daniel wanted with his question, and that'll teach you all a lesson. Don't ask questions. So I'm just kidding. I mean, that's every faculty meeting, I think, please, no one ask any questions. We don't want people to get spouting off on things. Okay, great. Let's move on. Wow, we're almost done with time, and we got to get to the chapel before, so that we can get things set up. Yeah, I was hoping to end a few minutes early, but we'll get there. Okay, a couple of things. First of all, homework for Monday. You have all the tools you need to do. However, I wanted to mention one thing about this because it looks a little confusing when you get to numbers, the bigger numbers. So let's just take a quick look at number 20 for homework. This is in 11.11. So we're at the very last section that we're going to do. So this is the very last problem that you're supposed to do. And so let's just explain what this is. It says, let's see, that we're going to use a equals 1. We're going to compute T3 of x and R3 of x. And then it wants us to graph this stuff. So just a minute. And graph between, let's see, 0.5 and 1.5. So they want you to graph this thing. So I thought that doesn't make a lot of sense. So let's just quickly explain so that you understand what to do with that, as well as the other ones in that section. So let's just, I can whip this off pretty quickly, I think, because this is an easy function. So we have the, I'll just write these down. So x ln of x, so this is going to be f, and this is f in evaluated at 1. Okay, so that's the function, the derivative. You remember the product rule. So we have 1 plus natural log of x. And then do the derivative of that. So let's see, we're at 0, 1. I'll make a new thing. Here's n, 2. Second derivative is just going to be 1 over x, which is another 1. Third derivative, and I'll go to the fourth derivative because I'm going to need that for this r sub 3. So this is somewhat familiar. There we go. So this is going to be -1, and this will be 2. Oh, we don't care about f in at 1. Okay, so the Taylor polynomial. So let's see, I'll just do this really quick. Taylor polynomial is going to be 0 plus 1 times x minus 1 minus, or no, plus another 1 over 2 times x minus 1 squared minus 1 over 6 x minus 1 cubed. So that's T3. So hopefully that doesn't shock you. It's pretty easy to figure out. So as far as R3 goes, R3 looks like this. You have 2 over c. We'll get to what that means. But that's basically just the function, this derivative evaluated at this tornado, all over 4 factorial times x minus 1 to the 4th. So here again, in order to understand what c is, we would have to rely on our understanding of the graph. But here's the thing, is we're going to be doing this along this, let's see, get rid of this, 0.5 less than x, less than 1.5. And so when I did this, I thought the easiest thing to do is just to think in terms of worst case scenario on this range. And so the biggest that could be is if c was equal to 0.5. I realize that that's not entirely accurate, but I don't care. I'm just doing my best here because it wants me to graph this thing. So here's my remainder, whoops, in highlighter. Remainder looks like this now, 0.5 cubed all over 24 times x minus 1 to the 4th. So here's what I did, and I think this is what they wanted us to do. Just so that you can see, I'll show you a picture. Where's my camera? There it is. Okay, look at that. Isn't that beautiful? Here, it's going to move too much. I don't want to make you dizzy. There, now you can shove it in the middle and zoom in. Okay, so here's what I did. I don't know if this is exactly what they want you to do, but I'm not going to be able to tell what you do. But when you read the book and you're like, oh, it wants you to graph something. So here's what I did, just so you know. I have the original function there, that's y1. I have the Taylor polynomial, that third Taylor polynomial, you recognize that hopefully, that's y2. But I have those turned off. So if you know how to use a Texas Instruments calculator, you know that when this is not highlighted, you're not going to graph those. And then I've graphed the difference between those. So basically, I take that Taylor polynomial, I compare it with the actual function, and I say, what's the difference? And I do the absolute value of that difference. And then let's see. Yeah, I guess this, oh, wait a minute. Oh, I was wondering why it was so far off. Yeah, I haven't got the right thing there. Let me fix this. Let me just a sec, I'll fix it. There we go. Give me a sec. Go down, go down. Sorry. Yeah, my graph didn't look right. Now it's going to hopefully look better. Let's see, times this, times 24. I forgot my 4 factorial. Okay, now that's better. Let's see, is that there? Okay, there they are. So I think I'm going to have to zoom a little bit more. So I'm going to graph these two. So the first thing is that's the actual difference, the actual error. You can see, and this is from negative 0.5 to 1.5. So the actual error, of course, is a little bit bigger on the ends. And then this is the predicted error. And you can see that the predicted error is always bigger than the actual error. And so I think that's what they wanted you to do. And now I've done it for you. You probably don't have to do it yourself. But anyway, I read that over and I was a little confused myself, to be honest, about what they were looking for. And so that's that. Okay, instructions. Here's what's happening is I have put on your Moodle page this, not that, this. So you'll find the this is the actual final exam that I gave students last year. So the actual final, I have not got the answers yet. So we'll talk about that in a minute. Your exam is in this room, Wednesday, April 30th, 7:50. If for some reason you can't come to the exam at that time, even if you've communicated to me about this already, please do it again because I will have forgotten. So if for some reason you have to take it early or late or whatever, I don't care, let me know. Okay, now something about this. Here's the deal is I don't have the answers to this yet, but I will on Monday. So on Monday, what we'll do is Monday, here, I'll write this down here so that you all can see and enjoy. So Monday, this is April the 28th. This is optional, optional day. What are we going to be doing? So what we're going to be doing in here is we're going to go over this practice test. Well, it may not be the first thing. Actually, the first thing that we're going to do is we're going to deal with any homework. Number 2, homework woes. Woes. So if you have homework woes, that is, maybe you didn't upload your homework. I don't know. I'm going to be dropping some zeros on some people if you don't get it uploaded. So homework woes, bring your homework woes to me that day and the practice test. And then number 3, whatever. Whatever else you want to discuss, we can do. But probably in this order, not the order it's given here. Probably we'll do homework woes first. And if there are only 2 people here, I will be helping those 2 people. I imagine that I won't have a lot of people because some of you said this is your first class of the day, in which case you'll probably still be in bed at this time. But whoever is here, I will help you deal with whatever homework, and we will talk about practice tests. And if you don't want to come, that's fine. You'll just come on Wednesday, April 30th, and have a joyous final exam. So I think that's it. Stick around if you have questions. Don't forget to go to the awards chapels. If you're in the natural and social sciences, it's in the chapel.